Hello everyone, hope you are doing well. So today we'll be learning how to find missing angles in questions involving parallel lines. So let's start. So to find the missing angle, we generally follow these steps to do the question easily, right? So these are the steps. Let's focus. So first of all, whatever question is given to us, which is involving parallel lines, what we first do is we should focus on what angle or angles are given in the figure. Like whatever angles are given to you, 60 degrees, 150 degrees, whatever it is given, focus on that and the angle that we need to find out. The angle that is missing. These are the two things that we need to focus on first of all, right? After that, what we need to do is now see if there is any direct relationship between the given angle. Suppose the given angle was 50 degrees. So now you need to see, is there any direct relationship between this 50 degrees which was given to you and the angle that we need to figure out. What I mean by direct relationship? Direct relationship means, are they corresponding? Are they alternate interior? Are they alternate exterior? Are they co-interior? Any property that we learnt in the previous video, right? Because if they are having a direct relationship, we can directly use that property and figure out the missing angle, correct? So this is our first step, that we need to find out the relationship between the given angle and the missing angle. So if there is a relationship, if it is a yes, if there is a relationship between the given angle and the missing angle, then what we do, we use the relevant property to find the missing angle. They could be corresponding, they could be co-interior, they could be alternate exterior. So if that is the case, then directly use that property that we have learned in the previous video, use it and you'll be easily figuring out the missing one. If that is not the case, then we'll follow the next step. But before we move to the next step, let's see an example wherein we can directly use the property to figure out the missing one, right? So let's move to the next slide and see how it works. So this is the question, find the value of A. So in your figure, there is a variable A, there is an angle A as you can see over here. We need to figure out the value of A. See, first of all in the figure, you will see these arrows are there on the lines. These arrows denote that the lines are parallel, correct? Since the lines are parallel, it means we can, the questions which have been provided to us, we need to figure out the missing ones using the parallel lines property. Somewhere we would be using the properties, right? So since the lines are parallel, let's focus. AB is parallel to CD. First of all, yes, it's parallel. So I've written, since line AB is parallel to CD. And transversal, if you remember, we learned in the previous video that transversal is any line. Suppose these are the two lines given to us. They could be parallel or non-parallel. Transversal is any line that touches these two lines at two distinct points. Like it's touching the first line at point A, it's touching the second line at point B. Right? This was our first line, this was the second line. Similarly over here, AB is one of the line, CD is the second line. BC and BD both are acting as the transversal, because BC, it's touching the first line at B, second at C. If I talk about BD, it's touching the first line at B, second at D. So both are acting as the transversal. Now how will I choose which transversal I need to take, which line I need to take as the transversal to solve for the missing angle? So always remember, we'll be choosing that transversal which is on which the missing angle and the angles that are given to us in the question are marked. So if you look at it, 55 degree, it's not marked on BD, it's marked on BC. Similarly, A and 60 degrees, 60 is there on BD, A is there on BD, but 55 was not there. So that's why I chose BC as a transversal, because it is that side which is containing all the angles that I need to figure out what A is. That is why I'm taking BC as the transversal. I hope it's clear to you, right? Now let's see, is my A directly related to any of the angles present in the question? How would I check that? See, this A, any angle, whether it's corresponding angle, co-interior, alternate exterior, any of these angles, whenever they are formed, if I draw a diagram, these angles are always formed touching the parallel line and the transversal, touching the parallel line and the transversal. So here also if you look at it, if your AB is one of the parallel line, CD is the other parallel line, this BC is the transversal. Let me extend it to make things more clear to you. BC is the transversal. Then if I look at A, it's not just A, because A is touching the transversal over here, but it's not touching the parallel line, which is AB. So I have to consider this entire A plus 60 to figure out what A is. Because any relation corresponding co-interior, alternate interior, alternate exterior, that would only be formed with the angles which are touching the parallel line and the transversal together, right? So it's A plus 60 which is touching your transversal BC as well as the parallel line AB. So this A plus 60, you need to figure out what kind, is it having a direct relationship between any angle with any angle present in the question? Let's see. If I look at it, it is present inside the lines, right? It can be alternate interior, but alternate interior to it would be this one, between the lines and on the opposite side, which is not given to me, so I can't use alternate interior. Moving to the other one, co-interior. Yeah, co-interior could be there. Reason, see, this angle is co-interior, means between the lines. So if you see A plus 60 is between AB and CD, similarly 55 degrees is also between AB and CD, right? So they are co-interior. Co-interior means angles which are between the lines, inside the lines, and on the same side of the transversal. If you look at it carefully, A plus 60 and 55 degrees, both are on the same side of the transversal. This was our transversal. This BC was, this BC was our transversal. 55 degrees and A plus 60 are both on this side of the transversal. It's not like one is on this side and the other is on this. No, both are on the same side of transversal, so they are co-interior angles. So that's why we can use the co-interior angle property to figure out A plus A using 55 degrees and 60 degrees, correct? So that's how we are doing it. So therefore, what I can write, I'll be writing the names of the angles. Angle ABC and angle BCD are co-interior. Remember, we write the name. While writing the names, keep this thing in your head that we write that alphabet in the middle, which is on which the angle is getting formed. If I have to take A plus 60, the name of A plus 60 would be, look at the arms, it's starting from A, B, angle is getting formed on B. So writing B in the middle, ABC. That's how the name is angle ABC, correct? Similarly, if I say BCD, focus over here, BCD, angle is getting formed on C. It's starting from B, getting formed on C. That's why name is BCD. This 55 degrees. I hope it's clear to you, right? So angle ABC and BCD are co-interior. Therefore, by using co-interior angle property, angle ABC plus BCD would be equals to 180 degree, because reason is co-interior angles are supplementary. Supplementary means their sum would be 180 degree whenever the lines are parallel. We have been given with parallel lines, so their sum would be 180. That's why A plus 60 plus 55 degrees is 180. If I solve this equation, A would be equal to 180 minus 115, which gives us A as 65 degrees. Means we solve the question directly by using direct relationship between the given angle as well as our missing angle, right? I hope it's clear to you. Now see, what will we do if the angles are not directly related to each other? So for that we need to focus on the third step, which says if your given angle and the missing angle are not directly related, then what we do, we observe the figure carefully and observe the entire figure carefully and see which angle in the entire figure, you have to look at the entire figure, see which angle in the entire figure is making a direct relationship. Direct relationship means corresponding, alternate, interior, any property with your missing angle. I'm repeating, what we have to do, we have to just look at our figure and see, focus on our missing angle. Our missing angle is forming corresponding co-interior, alternate interior, alternate exterior with which angle, which point in the figure, right? Whatever point it is, mark it as some angle. Maybe say it's angle A. Now first of all, our first step would be we have to figure out this A's value using your given angle, and then we can use the direct relationship between this A and the missing angle to finally get the answer, right? I'm repeating, if your missing angle and the given angles are not directly related, what we do, we just focus on our entire figure and see our missing angle is making corresponding co-interior, alternate interior, alternate exterior with which part of the figure, which point in the figure. Whatever point it is, mark it as some angle. Figure out that point, that angle that you have just marked, maybe angle A, using your given angles, right? Once you have that your angle A, you can directly use it to figure out the missing one. Means this, if the question is of this kind, it will be having more steps than the previous one, correct? Now the question arises, how do we figure out angle A? So this angle A, or the angle that you observe the figure and get to know, right? How do we figure out that A? So this angle A generally is figured out using either the properties that we have learned in the previous video related to parallel lines corresponding all of that, or we can use linear pair property, vertical angle property, or complete angle property to figure out this missing one, right? This angle A. There could be some others as well, but generally these are the ones that we use, and it will fetch us the angle that is required to figure out our missing main angle, right? Also keep one thing in mind, that the same problem could be solved using multiple ways, but the answer would be the same in all cases. Okay, so we can try doing the questions using different ways. Always and always the answer would remain the same. It's just that there are multiple ways, but we should try to solve using the most simplest way, right? So let's focus on these properties. What is linear pair, vertical angle and complete angle property, and then we will try some questions related to the more complex ones, right? So what is linear pair? Linear pair means, as the name itself says, linear pair means, okay, so linear, it's derived from the word line, right? Pair means when there are two things, correct? So the name is itself hidden in the meaning is itself hidden in the name. Linear pair means when two angles are making a straight line. So linear pair, when two angles get formed at the same point making a straight line, they are called a linear pair. Look at the figure. This angle APB, this angle APC, they are getting formed at the same point P, correct? And when you draw a line through it, it's making a straight line. So such a figure, whenever you'll be framing, you'll be saying that this is a linear pair because two angles are getting formed at the same point making a straight line. Always remember, the sum of angles in a linear pair would always and always be 180 degrees. Why is it so? If you have ever seen a protector, see, it's constructing a 180 degrees angle, isn't it? A straight line, semicircle, correct? So that is why the angle APB, because angle is getting formed at P, and angle APC would give you the sum as 180 degrees. We can directly use this result in solving complex problems, right? I hope it's clear to you. Now coming to vertical angles. Now what are vertical angles? Vertical angles are when two lines intersect as shown in the figure. Look at the figure. Here our line AB, this line, it's intersecting CD in such a way like this. So whenever two lines intersect in such a way, then the angles that are formed on the opposite side of the vertex are called vertical angles or vertically opposite angles. Now how to choose that vertex? Vertex is that point in case of vertically opposite angles where these two lines are meeting. So AB and CD are meeting at point O. So the angles which are in the opposite direction of this vertex would be called vertically opposite. For example, in this figure, if you see, angle 1 and angle 3 are vertically opposite. Why? Because if you see, 1 is above the vertex O, 3 is below the vertex O, correct? So they are vertically opposite, and remember, vertically opposite angles are always and always equal. That is why 1 would be equal to 3. Similar way, if you look at 4 and 2, 4 is on the left side of the vertex O, 2 is on the right side of the vertex O. That's why again vertically opposite, so they would be called they are on the opposite sides of the vertex, so they would be called vertically opposite and their values would be equal. I hope it's clear to you. If there is any doubt, you can ask in the comment section, right? Let's move to the next slide now. Complete angle. Complete angle, as the name itself is telling, complete angle means the angle which is complete. So if you look at the protector, this is 180 degrees, right? When this circle will get complete, 180 plus again 180, which is 360 degrees, right? So whenever an angle is having exactly 360 degrees value, it is called a complete angle or a full angle. I hope it's clear to you. Complete angle or full angle, right? Remember, the sum of all the angles in a complete angle is always 360 degrees. Why is it so? Because if you look at it, 1, 2, 3, 4, see, half of the semicircle was up till here. Then from here, one more semicircle. We know that one of the semicircle is 180. Again, this semicircle, 180 plus 180 is 360. That's why the value of a complete angle is always 360 degrees. So it doesn't matter how many angles are included in the diagram. If it's completing a circle, if it's making an entire revolution around, then the sum of angles present over there would be having the sum 360. That is why angle 1 plus 2 plus 3 plus 4 would be equals to 360 degrees. And if any one out of the 4 is missing, you can easily figure out the missing one using this property, right? I hope all the three are clear to you. Okay, so now let's discuss some questions related to the third step that we were discussing, when your missing angle is not directly related to the angles given in the figure. Then how to solve it using the properties that we just studied. So look at the figure. They are saying find the value of A. We have to figure out what A is. First of all, arrows on the lines are given to us. It means lines are parallel. So I can use the parallel line properties to solve the questions, right? So first of all, here line PQ is parallel to RS using the figure, correct? Your AB is the transversal because it's touching PQ at Q and it's touching RS at point S. Touching two different lines at two different points, so it's the transversal. Remember, I can write AB as the transversal, AQ, QS, anything, because if a line is a transversal, it would remain the transversal no matter if I take a small part out of it or the complete one, right? So AQ is also transversal to PQ. AB is also transversal to PQ, right? I'm writing it in general that AB is transversal. Okay. Now see, as I told you that you have to figure out, focus on the missing one, that the angle that we need to figure out. So in this case, the angle that we need to figure out is angle A. See if this angle A, is it directly related to 115 degrees given in the question. Let's see. To make things more clear to you, I'm just extending the lines so that things are clear to you. So this line PQ is parallel to RS. This is A. See, AB is the transversal, so A is below the parallel line touching the transversal. If I have to use the corresponding angle concept, then below the other parallel line touching the transversal is this angle. It should have been there. If it would have been there, I would have directly used it and say A and this angle, maybe this angle, say angle 1 are corresponding, I would have figured out. But angle 1 is not given to me, so I can't use that. If I want to use alternate exterior, because this is outside the line, then alternate exterior to this would be outside the other line on the opposite side of the transversal. This is on outside, so outside are the two angles, this one and this one. Outside and opposite side. Alternate exterior would be this one. Again, this is missing, I can't use. Alternate interior I can't use because A is not present inside the lines, right? Between the lines. Coming to co-interior, again I can't use because A is not present between the lines, correct? Now moving to the step third that we just discussed, that whenever the missing angle is not directly related to the angle given in the question, what we do? So what we do is, we see, is there any angle in your question that we can use that is having a direct relationship with A? So yes, there could be multiple angles, but I am using this one. that this A is below the parallel line touching the transversal AB, and also angle 1 is below the other parallel line touching the transversal AB. So 1 and A are corresponding. Now this 1 is acting as the angle A, remember in step 3. So I need to figure out what this 1 is. Once I have this value of angle 1, I can easily figure out what A is. So to figure out what angle 1 is, using the properties that we have learned. Clearly angle 1 vertically opposite we can't use because there is no angle vertically opposite to angle 1 in our figure. Complete angle I can't use because I have not been given all the remaining complete angles. Right? That could be part of complete. Now coming to linear pair, I can use that. Reason, this angle 1 and 115 degrees, they are getting formed at the same point Q, making a straight line. That is why from figure I am writing angle 1 plus 115 degrees is equal to 180 degrees, linear pair. From there, if I solve this equation, angle 1 would be 65 degrees. I hope it's clear. Now coming to also angle 1 and angle A are corresponding angles. I have angle 1, so now I can directly use the relationship between angle 1 and A to figure out what A is. Right? So let's use it. Angle 1 and angle A are corresponding angles. Therefore, using the corresponding angle property, A would be equal to angle 1 because corresponding angles are equal when the lines are parallel. Since angle 1 was using first equation is this one. Angle 1 was 65, and since A is equal to angle 1, so A would also be 65. I hope it's clear to you. Okay, let's move to the next question. If you're having any doubt in this question, you can put your doubts in the comment box. I'll resolve them. For the time being, let's move to the next question, which is question number 3. Again a question wherein our missing angle is not directly related to the given angle. Let's see how it is not. Here arrow is there on line EG, indicating that EG is a line parallel to BC, right? EG is parallel to BC and this AB is acting as the transversal, correct? So if this is the case, to make things more clear to you, let me extend the line BC so that a clear picture is there in front of you. Now focus. See, if I look at my angle X is above the first parallel line touching the transversal here. So corresponding to X would be this angle, but this angle's value is not provided to me. I've been provided with this entire 150. So I can't use corresponding angle. If I have to use alternate exterior angle property, alternate exterior means why? Because this is outside the line. So outside this parallel line touching this is our transversal, right? One second. Okay. Outside the parallel line, this was outside the parallel line and touching the transversal. This was our transversal. So this would be this angle, alternate exterior, touching the parallel line, touching the transversal, outside the line and on the opposite side of the transversal. But this entire angle's value I don't know because 90 degrees this complete one, correct? So I can't use alternate exterior as well. Now coming to, can I use any other? Co-interior I can't use because this angle is not between the parallel lines, correct? Alternate interior again I can't use, again the same reason, because this angle is not between the line. X is not between the lines, right? So that's why X is not directly related to your given angle, which is 150 degrees. Now what else I can do? See, I told you whenever such case is there, we can use 3 properties: linear pair, vertical angle and complete angle, to make things easier for us. Clearly, vertical angle and linear pair are not getting formed at the point. But I can see there is complete angle over here. Focus. A circle is getting formed. Focus over here. right? This is the circle. I already know that if I can suppose this angle as angle 1, this mark is there, it means this angle is 90 degree, and this entire is given angle is given to me as 150 degrees. So I have the other two angles, so I can easily figure out what angle 1 is, right? So let's do it. Figure out what's angle 1 is. I'm assuming this angle to be angle 1 and using the complete angle property to figure out what x is. So from figure, angle 1 plus 150 degrees plus 90 degrees equals to 360 degrees complete angle. So if I solve this equation, angle 1 would be equal to 360 minus 240. Therefore, angle 1 is 120 degrees. Now clearly, now also angle x doesn't have a direct relationship between any of the angles as we have discussed, right? So what I can do, angle x, if you look at it carefully, this angle 1, because EG is parallel, FG is parallel to BC, right? Your FG is parallel to BC. This AB is the transversal, or BF is the transversal, you can say. Because it's the complete line, I can write AB or BF, it means the same. This line is the transversal, right? So this angle is above the line touching the transversal. So this angle above the other line touching the transversal would be corresponding to it, yes or no? Right? So I'm naming this angle as angle 2. Now, angle from figure, angle 1 and 2 are corresponding angles, and these lines are parallel. This one is the transversal. So I can directly use the corresponding angle property. It states that if two lines are parallel and there is a transversal, then the corresponding angles are equal. So from there, angle 1 would be equal to angle 2. Correct? And we have angle 1 as 120 degrees. So angle 2 would also be 120. Correct? I hope it's clear to you. Now moving forward, because we need to figure out what x is. See, angle 2 and x, are they related somehow using the properties that we have just studied? Yes, they are. Focus. If you look at x and 2 carefully, x and 2 are getting formed at the same point F, making a straight line like this. So x plus 2, they would be equals to 180 degree, reason linear pair. From there, x plus angle 2 is 120 degrees. So x plus 120 is 180. That's why x equals to 180 minus 120, and hence x equals to 60 degrees. I hope it's clear to you, right? So this way we can solve the problems. And the best way to learn how to figure out these problems easily using the best possible ways, because there are multiple ways of doing the same problem, is only practice this. You can use the steps that I taught you in the previous beginning slides. That would be helpful. And most importantly, practice as much as you can. That would help you in figuring out which method should we choose while doing a particular problem, right? So that's all for the day. If you have any doubt, anything that is not clear to you, you can ask me in the comment section. I'll be making the next video on some more complex problems related to these parallel lines and transversal, wherein we'll be discussing what we can do when the diagrams are more complicated, when there is more than one set of parallel lines involved in the questions. Such kind of questions we'll be dealing with. So thank you, have a nice day, and if you like the video and if you find it useful, please do like the video and subscribe to the channel. Thank you once again.